Welcome to our education program this morning. My name is Kim Toll. I'm the extension agent in Fayette County. And this morning we have Gary Hawkins. Gary is an assistant professor with water resource management with crop and soil sciences at the University of Georgia. And this morning he is going to talk about the basics of erosion and sedimentation. Thank you all so much for joining in this morning. And thank you, Gary, for providing us with this presentation. We really do appreciate it. I would ask everyone, if you do have a question, to please type it in the chat box. Or if you feel comfortable and would like to unmute yourself and ask a question, you can do that maybe at the end of the presentation this morning. But during the presentation, if you would please keep your mics muted, so that way we can hear the presentation and be able to move forward this morning. So Gary, thank you so much. I really do appreciate it. And we look forward to hearing about erosion.
Sounds good. Thanks, Kim. I'm going to turn this video off now so that maybe the bandwidth won't be as bad. But again, thanks, Kim, for inviting me, and thanks for everybody being here. So Kim asked me to talk a little bit, like she said, about erosion and sedimentation and how that affects some of our properties and in general, what is erosion. I told Kim earlier that this is probably a little bit more of a housetop, looking at it from the top of a roof and a little bit higher up than just on your property. But I wasn't sure how detailed we need to get today. So we'll go through some of the basics. And like Kim said, if you've got questions, write them in the chat box, or we can talk about them at the end of the thing. And then Kim and I have talked about too, maybe sometimes in the springtime, and Kim and I haven't figured out dates or anything, but kind of having a show and tell day to go along with all these webinars where I can bring some of the materials, and I'll try to show you some of the pictures of what some of these erosion materials might look like, sometimes through the presentation or at the end. But if we could have, or if we have a quote unquote show and tell day, kind of a 4-hour type thing. Again, Kim and I haven't talked about dates in the spring, but I can bring some of those products and let you then kind of feel and touch them and see them and kind of go from there. So we'll get started. And like I said, if you got comments, questions, just put them in the chat and we'll see how we can best answer those. So as we get started, I mean, we've seen this one over these past couple of webinars, but everything starts with a hydraulic cycle or hydrologic cycle or the water cycle. I know we all learned this in 4th, 5th, 6th grade, and we get it back from time to time. But this is just a really busy water cycle, but I think it includes a lot of, and actually all of the different parts and pieces of where water comes from. And so, the basics we learn in elementary school and middle school is the sun causes evaporation, and then it condenses in clouds, and it rains, snows, or sleets. Then it runs off and goes back into the rivers, lakes, and streams, goes back to the ocean and continues that. But then we also have all these other different things. And then like the surface runoff here is that stormwater we talked about a couple weeks ago. The water holding in these fresh ponds and lakes and water quality issues from there. And we talked a little bit about drainage. So then that comes into some of this groundwater flow here. So again, the water cycle is where all this starts. And so as that water hits the ground, where is that water? And so this is a picture typically we will see a lot of when we talk about water on the surface. And so, and you've probably heard it, that 96% of our water on the face of the earth is in the oceans, with only about 2.5% of that being fresh water that we can use. And then if we work that on down, we're looking at very, very small amounts of water in our rivers, lakes, ponds, and streams that we can actually use. And then why is that important? Because as we start thinking about erosion, carrying that soil, carrying that pollutants, be it nutrients or anything else we put on the ground, into these water sources causes a water quality problem. So that's where erosion, and then more importantly, the sedimentation comes into play. And so we'll start looking at that a little bit as we go through this presentation today. As we start thinking about water quality, sediment, as you see there, is the #1 non-point source pollutant. Now, a lot of times we hear that this comes from agriculture, and I will admit that's true, but we also get sedimentation and runoff, as you see here, the red soil come out of this little creek from anywhere. It can be from construction, it can be from our backyards, it can be from roadways, it can be from agriculture. So sediment is that #1 water quality issue, #1 pollutant that we have in our river, streams, and lakes here in the U.S. and probably around the world. So let's start with erosion, just some definitions. What are the types of erosion? Because if we know what types of erosions we have, then we can start thinking about how do we prevent some of this from occurring? How do we prevent some of this erosion from occurring? And then what are some of those factors related to erosion? So just some schoolyard, if you want to call it that, definitions, and I'll try to read some of this, but I probably won't read all of it. But definition of erosion, as you see there, is the process by which the land surface is worn away by the action of water, wind, ice, and gravity. We see water erosion all the time when it rains. We talked about drainage and stormwater a couple of weeks ago. So as that stormwater moves off the land, moves across the land, and then into our river streets, rivers, streams, it carries that sediment with it. We've seen that. We don't see very much wind erosion around here. However, if you go to some of the more rural areas, more agricultural areas there in Fayette County and elsewhere, especially during that time of the year when they're harvesting or when they're planting, if they don't use some kind of cover on the ground, like a conservation tillage or something like that, you may see on some of those windier days, some of that soil moving through the wind. And then if you think back, the Clean Water Act and some of the Dust Bowl days, that's where some of these federal agencies, specifically the Soil Conservation Service, or now the NRCS, Natural Resource Conservation Service, got started, because erosion and wind erosion during the Dust Bowl was actually blowing dust from Kansas and those areas of the country over to Washington, D.C. And as that came over Washington, D.C., they started some of these conservation agencies, the federal agency. We see a little bit of ice, but we don't see very much ice erosion here. And if you go a little bit north of here, well, a lot north of here, we see a lot more ice erosion, and definitely we see gravity erosion. And that's where, if you look at a stream and that stream has started to undercut through or as a result of stormwater, those banks start hanging over the creek, and then gravity eventually will knock that overhang of the creeks into the creek. As more water comes through, it erodes that soil away and then starts undercutting again, and it falls in. So that's kind of gravity erosion. Or if you see on the side of hills, as that material starts sliding down the hill, that's gravity erosion. One way we measure erosion and really sedimentation is something we call an Inhofe cone. And so you'll see these sometimes where we take a liter of water with the sediment. So if we catch water out of a creek or a river or stream that has a lot of sediment in it, we can use these Inhofe cones. And as you see there on the right, you fill it up with a liter of water, which they didn't do here, but then it'll settle out. And it gives us a good idea of actually how much sediment and really what type of sediment is in that water. So just wanted to show you kind of some of the ways we measure this stuff. So here's the types of water erosion. The first one here is splash erosion. And a lot of times we don't see this per se, unless you're out there watching it. And if you're geeky like me sometimes, and you just go out in the backyard or front yard and you sit there and you watch it rain, and you watch the raindrops hit the ground, especially the bare ground, you'll start to see some of this occurring. And what this is that's the initial form of erosion. So as you see here, it looks like a little bomb has gone off. So as that raindrop, which has a lot of energy in it, hits bare ground, it causes a lot of these smaller particles to dislodge and some of the larger particles, but you see how it dislodges. And if you ever go out to an area that is really void of vegetation and you see the little rocks sitting up on top of columns of soil, the reason that occurs is a lot of this splash erosion has hit the ground, hit the bare ground, and eroded that away. Whereas when it hits that rock or that pebble, the pebble will actually absorb a lot of that energy and then let the water drain down the side of it. So that's kind of how you can see splash erosion, or at least the effects of splash erosion. But go out sometimes, like I said, you want to be geeky sometimes and go out and just watch it rain on bare soil and watch it splatter. And that's why a lot of times you see the splatter up on the side of fences or whatever because of that splash erosion. So once we have splash erosion occurring, then as that water, as we have learned, water is going to flow downhill. So that water will hit and then it'll start flowing downhill. And as you can see here, and it's hard to see any kind of erosion, but that water in the first couple feet will actually flow as a sheet. So think about water flowing across your table. If you pour, like, let's say a 5-gallon bucket of water across your table, you know how it's just real thin and it would roll across that table. Well, sheet erosion is that. It runs across the land, very, very thin sheet, but it can carry that soil that has dislodged from splash erosion. This will go for 2-3-ish feet is kind of the general thought process, maybe a little bit further, but just a very short distance. And then what it'll start doing is it actually starts reeling. It starts joining and forming little channels. And those channels then can run for 10, 20, 30, 40 feet or so. But these reels are typically on the order of less than a foot. So you see them here where the water is starting to run down the hill, very shallow ditches. And these are trenches, and these are easily filled in. Come back with a tractor or skid steer or something, and we can fill these in real easily. But if we let this keep going, water is going to flow downhill. It's going to gather speed, and the faster that water moves, the more sediment it can transport. So if you've ever gone kayaking in a creek or river and you get to a real low area where your kayak's just about bottoming out on the bottom of the creek or river, just sit in it for a few minutes, again, kind of the geeky side of you if you want to, and watch how those pebbles and that sand on the bottom of the creek just moves, or just go to a creek and watch it move. But so as these reels start forming, the faster that water moves, the more sediment's going to move. The more sediment it moves, it would erode here on the bottom, for instance, where I'm pointing to, would erode the bottom of that little channel. It would undercut this, like I talked about a minute ago with a creek or river, and then this part would fall in from gravity, then that water would catch it and move it. Well, if that occurs a lot, then you start to get this on the bottom right-hand corner, the gully. And the gullies are typically in that 3, 4, 5, 6 and bigger range. So if we can slow down and stop splash erosion, it doesn't necessarily slow down sheet erosion. We still get a little bit of soil moving. I'm talking very, very little. So a ton per acre per year type thing. So very small amounts. But if we can stop that, then we can slow down or stop the reels. And if we slow down and stop the reels, we can slow down and stop the gully. Now, obviously, this would take a lot more than just a tractor with a little bit of dirt moving to get it back in place. So this is what we want to avoid. And this is just another kind of cartoon drawing where we have splash erosion really over the whole thing, but sheet erosion is going to occur in that first couple feet of movement. And then as it starts channelizing, you're going to start getting reels. And then typically at the bottom of the hills, you'll get more of the gullies. And then the gullies can actually work their way back up as we go. So that's what we look at when we talk about some of the types of erosion. Some of the other types of erosion on a larger scale then is the natural erosion. And so you see these from the Grand Canyon, Providence Canyon in Southwest Georgia and other places that Natural erosion is just that is going to occur without human activity. Wind erosion, water erosion, those type things are going to occur. You see some on the coast. So you see the wave actions eroding the beaches away or building the beaches up. So that's kind of that natural erosion. And then we have accelerated erosion, which typically is going to be due to human activity. And so the left-hand picture here is just where they widen the banks of this interstate. And I think this was down actually near Tifton or a little bit north of Tifton. But you can see as they built that road up and expanded the shoulder of that road, they had to cut into this underlying rock. And so that's going to cause that erosion to occur. The right-hand picture is just an agricultural field where just the human activity of plowing that field and getting it ready for crops opened up that soil surface and opened up that soil so that we can go through there. So did anybody answer Ms. Joyce's comment, Kim, about is there sound?
We're good, Gary.
Okay, thank you. I just wanted to make sure. So then some of the factors affecting erosion, as you can expect, would be climate. So as the climate changes over the past 10, 20 years or so, and I was actually reading an article yesterday on the plane back from Missouri, where the climate is changing, where we're starting to get, at least here in the Southeast, more intense storms. We're not necessarily getting any more rain. And I'll show you a chart here in a few slides about how much rain and when we get rain typically here in Georgia. But we're not getting necessarily any more rain, but we're getting more intense rains. And so what that means is if we used to get, let's say, half an inch every afternoon, we might now get 1.5 inches every afternoon. And I know it wasn't every afternoon, but and so we get more intense rains, which then puts more pressure, quote unquote, on the soil to absorb it. Well, the soil's not going to absorb any more water. And so it's going to absorb what it can, typically 1/2 inch per hour. So if it's raining more than that on an intensity scale, more than 1/2 inch per hour, then anything above that 1/2 inch is going to run off. As that water runs off, it can and will potentially move soil and anything else with it. And then that's where that erosion comes in. Topography also has a big influence on erosion. So think about, like I said, a tabletop. If everything was flat as a tabletop, water typically is not going to go anywhere. It's not going to move. But as we start tilting that table just a little bit, water is going to start moving downhill. And the steeper that tabletop is, the faster that water moves, the quicker it gets off, the more speed, and then the more sediment it can move or more soil it can move. So the size, the shape, the slope characteristics, as you see there, and this is of the watershed, but watershed in your backyard or watershed as a whole can move more water off of that property. And then the faster that water moves, the more it can transport sediment. So this is just, like I mentioned previously, this is a 30-year average rainfall data. And you think about it, in July is when we get the most rainfall. And that's typically these afternoon thunder showers. So we get them. We get the heat during the day. That heat evaporates a lot of water. That water then condenses and it goes all back to that water cycle we saw on the second or third slide, where it goes back, it condenses, it gives us that little 15-minute rain shower in the afternoon. And then it goes on the rest of the day. And then the next day it evaporates and goes through this process. But you can kind of see there where we get most of our rains. And so that's why, and those are the times that we need to really start thinking about erosion, but we really need to think about erosion year round. But just July is at the heaviest rain precipitation. Gradients, another thing we need to think about. So again, it goes back to the topography, but how steep is our slope? So again, if your backyard is really flat, you're not going to get very much speed when that water runs off your backyard. But the steeper you get, the more water potentially is going to run off. the faster it can run off and the more sediment it can carry with it as it moves off the ground. So gradient's another way of looking at how fast is that water going to move off of my property, or where do I need to put some stormwater management practices like we talked about a couple of weeks ago to stop that water or slow it down. Soil type is going to affect it as well. So this is a Tifton loamy sand, which is pretty much from Macon south. And then here in the northern half of the state, we're going to get more of the Cecil red clay type soil. And as you see, the Tifton is going to be more erodible, whereas the Cecil is going to be a little bit less erodible. And that all has to do with the compaction and the connectiveness of the soil particles. So Tifton is going to be more of a sandy material, so there's not really much to hold it together. Whereas the Cecil soil or the clay looks like little sheets of paper if you really blow it up. So they can kind of interconnect with each other a lot better. And so it has a little bit of more resistance to erosion, but we can still get erosion on the clay, but we just get a lot more on the Tifton soil, which is kind of not a good thing, but with Tifton soil being in the more coastal plain, it's a little bit flatter. So we still get erosion down the bottom half of the state or the lower half of the state. And when we start to get erosion on those soils, it really makes those gullies and rills and gullies a lot deeper, a lot quicker versus some of the soils up here. But as you've seen up here, we get a lot of those as well. Some of the other factors is vegetative cover. So if we have some vegetation on the ground, as you see here in this picture, that vegetation, and on the next slide, I'll kind of show you what it looks like, but it absorbs that energy. Remember, I talked about looking at the little columns of soil under the rocks and how the rocks or pebbles absorb that energy. Well, the grass does the same thing. It absorbs that energy and lets those raindrops and that rain and water then gently flow down to the ground. It binds those soil particles together, so those root systems in there kind of holds that soil together and helps it resist erosion a little bit more, slows that water down. So if you think about having to go through, I'll say an airport, just because I came to Atlanta Airport the other day, if there was nobody in that airport, you could almost run through any terminal you wanted to or any concourse you wanted to. But the more people gets in there, the harder it is to weave your way through. And that's the same thing with grass and water. If it's wide open, that water can just flow downhill about as straight as it wants to. But all the grass, that water has to weave its way through those grass stems and such as that, and it just slows that water down. And then that kind of flows through the next ones there that I have shown. And then as that water slows down through the grass, it can actually infiltrate as well. So that slows it down even more. So this is just a picture of what that looks like. So again, with bare soil, we get that splash erosion you see here, but with grass or some other vegetation on the ground, the water drops will hit that leaf. It'll slow it down and actually just lets it run down the stem, and then it gently flows onto the ground and stops that splash erosion. Some of the other things that the grass or vegetation can do as well is it helps stabilize the soil. So if we've got a lot of roots in there, it opens up those pores in that soil profile. It keeps them open, as you see there with the tree roots or the grass roots in the top couple inches of soil. And as that grass and some of these smaller tree roots die off, it opens up channels. And so that water can get in and move down through the soil, and it stabilizes that soil versus on the left where that soil could compact down. And the more it compacts down, it gets quote unquote closer to a concrete type consistency where it's just really packed in, and that water has very little chance or less of a chance to get into the soil profile, so it runs off a lot quicker. One of the slides previously mentioned, if you have a grass cover, it slows that water down. So this is just, again, this is more in a pasture type situation. But as you see here, excuse me, the water is just running downhill, but the grass is laid over and it's actually protecting that soil. And then here's just another, if you've ever ridden down the road, seen grass on the side of the road. This is when I stopped just this side of Dublin, but you can see how the grass is laid down. So as the water came down this channel, this tall grass, which is probably about 12, 18 inches, it lays over and almost makes a carpet. So the water runs across the grass and never really per se touches the soil. And that does get down to the soil, but most of the water is going to run across that grass, so it protects that soil. So even in our backyards, if we have bare areas or where we know the water is running a lot, if we have quote unquote channelized areas in our backyards, if you have a good grass cover like this, the grass will absorb the energy initially, and then it'll lay down and actually let that water flow across it like a carpet, and it won't erode. Now you may have some erosion, but it won't erode as much as it would with bare soil. Again, and we've seen this one before, but in natural situations where we have no houses or we only have forests and such, we have very little of that runoff occurring. And again, this is going to be that sheet flow that's running off, and it's going to carry very, very, very small particles and a little bit of material off of the land. But the more and more houses we get put on, the more runoff we get. And so the more the runoff, the faster the potential runoff can be. And if it's on bare ground, the faster the water's moving, the more sediment it can transport, the more erosion more. So there's a couple of different parts. When we have erosion, that's the movement of that soil. Then we have sedimentation. And so we want to look at sedimentation on the back end of that erosion. And so the same way, I'll go through a little bit of definitions, some of the processes we think about with sedimentation, and then what are some of those everyday impacts that we see from the sedimentation. So a definition of sedimentation then is the process by which the eroded material is transported, moved down the hill, and deposited by water, wind, ice, and gravity. So deposited is when it actually falls out of that water column. And so this is, you see the picture here is a sedimentation basin. So this could be on a construction site, or if you're in a neighborhood, you may have one of these sedimentation basins in your neighborhood. And hopefully, if you don't have any construction going on right now, you wouldn't see this. It would all be grass. But as they building these new subdivisions and new communities, there should be one of these at the quote unquote bottom of the hill. And what that would do is catch all the eroded water, slow it down. And then as that water slows down, you see the sediment that falls out. This is just a rock check berm here to slow that water down more, to try to get all the sediment and fall out here. Some of that's going to get through, and then this is the exit pipe from the sedimentation basin. So erosion actually picks up the soil and moves it. Sedimentation is where that water slows down. I'll show a picture or two of that here in a few minutes, but it'll slow down. And then as that water slows down, all the heavier particles will settle out, as you see in this picture. So there's three different processes to erosion and sedimentation. So first is that detachment with the splash erosion we saw. So once those particles are dislodged, once they are, we'll call it free, and that water is moving downhill, it can pick up those particles. And as you see, then it transports those particles with the flowing of the water. And once it then gets down to, let's say, the bottom of the hill down here, then it slows down. As that water slows down, it's going to drop all the sediment out, or a lot of the sediment out. So that's that deposition. So the three processes, as you see there, it detaches it first, it transports it second, and then it deposits it third. And so a lot of times you may say, hey, but if we're going to deposit a lot of that material because it slows it down, why are our creeks and rivers so red when it rains around here? Well, clay particles are very small, and I've heard it say this way, and it kind of makes sense that clay particles, like I said earlier, is like a sheet of paper. So think about putting a sheet of paper and picking up a sheet of paper at your house or whatever and dropping it. It doesn't instantly just fall to the ground. it's going to float down, or like a leaf does, it just floats to the ground. And so the clay particles are that same way. They're just going to float as they settle. And if there's any kind of disturbance, I mean, even the slightest disturbance, it could pick that clay particle back up to where it came from, and then it starts floating down again. So a lot of times what we see in our creeks and streams and why it turns color is because of those very, very, very small clay particles that are just kind of floating in the water. But if you look at this here, if we came back up here, we would see a lot of the sand and the silt, the heavier particles, have settled out just below this line from the 2 to 3. This is in South Georgia, where you see the hill here, and I just took a picture so that if you looked at this little part of the ditch on the side of the road, it's really incised or really eroded away. And then as the water got down here, along with all the sediment in it, this is a flat area on that road. And you've probably seen this around these parts as well here in North Georgia. But as that water slows down, a lot of the sand, silts, and clays will start settling out. And that's where we get this sedimentation occurring. So we get erosion up here, and we get the transport down the hill, and then we get sedimentation here at the bottom of it. And then this is just a picture showing that transport. And you've seen, again, if you want to be geeky and you've got a little creek near your house, when it starts raining, go out and you can actually see this moving through and the sediment moving through. So then what are some of the everyday impacts of the sedimentation? As we start to get more sedimentation occur in our streams, rivers, creeks, even our streets, we get more, there's an increased likelihood of flooding. So if we have a channel, a stream channel, and it's designed to carry water, and that's what it's designed to do, or if you've seen some of these concrete channels and ditches, they're designed to carry the water and get it out of the way. Well, if any part of that starts to slow down for whatever reason, you start to get sediment building up. As that sediment builds up, now the water can't occupy that space because the sediment occupies that space. So then the water has to go a little bit higher, and when it gets higher, it moves outwards. And if we get a stream or a channel or something like that that's clogged up with sediment, then the water has to get higher, and it's going to spread out. And that's where we start to get the flooding. And I'll show you a picture or two of that in a minute. We get loss of soil productivity. So think about a yard or an agricultural facility where if we lose our topsoil and we're moving a lot of that topsoil away from erosion or by erosion, or if we're in the lower part of that field or that yard or wherever, and the sand, the silt, and the clay starts depositing at the bottom of the hill, then it's hard to get anything to grow on the hill where it eroded away from. Plus, it's hard to grow down in the bottoms where a lot of the sand will settle out. So we lose that soil productivity from the effects of erosion and sedimentation. We decrease our recreational value of our streams, creeks, and lakes. So if we get a lot of sedimentation in our streams, rivers, or lakes, we can't go fishing, or we can, but it makes it more difficult to catch fish, more difficult to go skiing, boating, such as those things. So the sedimentation affects us in that way. Obviously, we've seen it here after a rain, the nice, typically clean looking streams turn red. And so now you get water quality degradation. And so how does that play, and how does that affect our everyday lives? Increased cost of maintenance. So how many of you have seen around Fayette and other counties where about once or twice a year, the road crews in the counties or the cities have to go out and dig out the ditches, or every so often, because that sediment has moved from uphill and settled down in these low-lying areas of the ditch. And so they have to be cleaned out. If it settles in the pipes, the culverts going under the roads, that goes back up to the first bullet point. So if we get erosion or sedimentation in the pipes, if we're supposed to have a 24-inch culvert going under the road, and now we've got half of that with sediment in it, now it's not designed a 12-inch pipe or half of a 24-inch pipe isn't designed the same way to carry water, or it can't carry as much water as a 24-inch pipe. So then we start getting flooding back upstream of that culvert. So having to clean that out costs the county or the city dollars to move that sediment out of the way. And if we have the sediment occurring in our streams, lakes, ponds, or lakes, then the habitat in there also changes. So if we are losing our macroinvertebrates in these streams, then the fish are lost. If we lose the fish, then we lose the birds. And if we lose the birds and the fish, then we lose the fishing income. And so it also has an effect on that wildlife that we like to see in these creeks and streams. And it also loses that habitat. So if basically they don't want to live in a mud pile, just like we wouldn't want to live in a mud pile. So they're going to move elsewhere. This is just a picture of, flooding. So obviously, if this was a little stream that we used to cross, as you see the sedimentation occurring here, as this stream slows down, especially up here on the banks, it's going to settle out that sediment. And then it's just going to open up that channel, or what was an open channel to move water through is now going to be flooded. So this is a decent picture, but you've seen some of these before, how streets and things have been flooded due to sedimentation. Think about our streets. If we get sedimentation in the stormwater base or drop inlets, then that's going to flood the street, and then we have those issues there. Or if you've seen on some of the streets where that water is slowed down, and you have small little deposits of sand, silt, or clay on the side of the curb or next to the curb, what happens to that water? That water then floods out into the street, which then causes some issues with us. And as that water moves into the street, it can settle, it can deposit more of that sand, silt, and clay. And so it just makes that water movement further and further into our streets. So that's one of the impacts of having the sedimentation and erosion. The other thing is like we mentioned, loss of soil productivity. If you're an agricultural field here in the upper right, then if we lose that topsoil, then it's harder for these plants to grow in the clay, the tight clay versus an open topsoil like we see. If you have developed land in an urban area, if we don't have grass up here on the land, then you see the erosion and the sedimentation occurring here. Well, if that gets in this drop inlet here, or stormwater inlet, then as it starts clogging this up, then that water is just going to go further downhill or potentially come way out in here. So if we're driving by this area, then that's a flooding issue that we have to deal with from a vehicular aspect. The decreased recreational value, like we saw. So if these lakes get full of sediment, then again, the fish is going to move out. We can't go swimming, boating, fishing like we used to. So it impacts that recreational value of these water bodies that we like to go to. From again, another recreational value, if you get a lot of these sediments, depending on where that water's coming in, I'm not sure exactly, but you see here where we have a sandbar. Well, if we get these sandbars occurring, well, boats can't go across it. We can't ski across it. It slows that water movement down. So these sandbars then catch trash, as you see. So that's another issue. And also keeps some of the sunlight from getting to the bottom. So if it keeps it from the bottom, then those plants can't grow. And if the plants can't grow, then it gets back to habitat and such as that. One of the other things then is like we mentioned earlier, is water quality. So we like to go to the falls and see it like this. So we like you see these folks here, they're playing on the side of the creek. You might even be, as I heard somebody say the other day, wetting the line to catch some fish here in this little pool at the bottom of the waterfall. But if we get a heavy rain up here, especially, then we start getting the sediment moving through. So what water quality effect does that have? We don't see anybody fishing in that. We don't see anybody sitting next to it. Now it's possibly still raining, but I'm gonna go back one. That's a whole lot nicer to see than that. And then what is the effect of all this clay and sediment and silt and sand in this water is this pool will start to fill in and everything downstream of it will start filling in. So from a water quality standpoint, erosion and sedimentation is an issue we have to look at. I mentioned it earlier, if we start to slow this water down as we would in some of these culverts, and especially if we got check dams just south of or just downstream of some of these culverts, this pipe, which is more than likely 18 inches, you see it's probably got 2 or 3, maybe 4 inches of sediment in it. Well, if this is designed to carry X number of gallons of water with all the sediment in it, and this is probably, if it's 4 inches back up in the pipe, maybe a little bit thicker. So this is going to reduce the amount of volume that we can push through that pipe, and that's going to just cause flooding on the backside. Some of the other things, if some of these pipes get clogged up, then we get erosion occurring in different places. And that volume of water that we designed to move through these pipes now can't move through these pipes. We talked about habitat and wildlife. So again, if we get a lot of sediment occurring in these creeks and streams, well, then the fish need the oxygen, and the minnows and those macroinvertebrates need that oxygen in the water to live. Well, if you've got sediment on the bottom and you got a lot of sediment in that water, and especially if it's got a lot of organic matter in it, then the bacteria is going to use a lot of the oxygen in the water to degrade that organic matter. And then the fish don't have that oxygen. So again, they lose the oxygen from the organic matter, or in this case, it almost looks like this fish passed away because it got a lot of sediment on its gills. Well, if it can't transfer that oxygen through its gills because of sediment, then it's going to pass away. We get a lot of, just the habitat of, if there's no fish, then macroinvertebrates, the frogs go away. If the frogs go away, then the birds go away. And so that kind of affects the habitat and the wildlife around these creeks and streams. If we start looking at a larger ecosystem, again, like I was saying, if we lose the macroinvertebrates on the bottom because we're starting to get a lot of sedimentation on the bottom, then we lose the fish. If we lose the fish, then we lose the other macroinvertebrates like the dragonflies here, then we lose the frogs, then we lose the other animals and the birds and such as that. So it kind of has this hierarchy of, once you lose one, you start losing all the other animals around these creeks, rivers, and streams. And so just in summary, and I've got a couple more slides after this, but erosion sedimentation are natural processes, and we're going to occur, and they're going to occur no matter what we do. I mean, we can go to a forest and see erosion occurring, and we can see sedimentation. It's not really pronounced, and you got to really look for it, but it's still there. But the more activity we do on the ground as humans, from removing vegetation off the ground, from removing those type things, from channelizing the water and moving it faster and such as that, it only increases that erosion. And then as we move it to a lower area, then it's going to deposit, or sedimentation is going to occur. So again, as you see there in blue, erosion equals this detachment, so it removes it from where it's at. Sedimentation then deposits it somewhere else. And that last bullet being, if accelerated erosion sedimentation is not controlled properly on land disturbance sites, a lot of our resources are impacted, like we just looked at in the past couple of slides. And like I said, I've got a few more things, especially for homeowners. Then eroded areas around our yards really removes a lot of that topsoil that we need to grow our grass and our flowers and those type things. So if we can reduce that erosion occurring on our property, then we can keep a lot of that stuff, the topsoil specifically, that we need to grow that grass, which then helps with erosion. And then low soil has potential to cause issue of sedimentation downstream. And downstream can be on your own property, or it can be on your neighbor's property or your neighbor's property. Or if you're in a community, for instance, if you get erosion off of your property, let's say into the street, it goes into a storm drain, and then there's a stormwater basin, if that stormwater basin is a detention pond where it detains it, then that water will pass on through over time, but the sediment's going to reduce the volume. And then the HOA or the community is going to have to remove that sediment out of that detention basin so it can hold the water that it was designed to. And so with that, I'll finish up. And again, like some of the past ones, if you guys don't mind, while we're answering questions, scan this QR code and do an evaluation of how we did today or how I did today. But if y'all got any questions, type them in the chat, or like Kim said earlier, if you feel comfortable, open up your mic and then we can just talk through it.